Hi, this is Chip Epps with Reversing Labs, and I'd like to thank AttackIQ for hosting the Purple Hats event, their inaugural event this year. And for the Reversing Labs presentation, as part of the networking sessions, I want to discuss 5 ways to mitigate costly software supply chain attacks and really put it in the context of where are the tools today and how you can actually better find malware and mitigate those exploits against your business as we all go through various phases of digital transformation. So again, I appreciate AttackIQ sponsoring today's event. Just wanted to put a little shout out to them one more time. So let's start the discussion around what's really starting to drive more and more attention into the supply chain. And we heard it, I think, in other sessions earlier today. And I really appreciate the conversations around making threat-informed decisions and how actually, a lot of conversations around applications and the control environment. And I would argue in looking at the supply chain at large. But we've got a forcing factor now. We've got, the White House executive order with a specific call out to looking at the supply chain and demanding that organizations that are acquiring software, particularly on behalf of the government, the U.S. government, need to make some assessments about where they currently stand, and then start, in many respects, demanding a certain set of information, capabilities, if you will, requirements from their suppliers as they move forward. And so with that, I wanted to frame our conversation today around the supply chain, or what I'll call the software supply chain in particular, so it doesn't get confused with other production supply chains. But there are really several different phases. I think we're seeing various levels of maturity, whether they're looking at waterfall and where are they relative to agile or some hybrid. We're seeing references to the software development lifecycle, and now what does that mean in the context of more agile DevSecOps types of environments. And so I think what we see is and we'll talk about this a little bit further, but there's a variety of different tool sets that are in play today to look at what I would say where the engineering typically has an engagement in this process, and in what I'll call the secure what you buy conversation. I look at these as the engineering, the software developers. I would also say these are going to be quote unquote the software suppliers in some instances, and some of these quote unquote software suppliers will end up being vendors or third-party participants in other people's software. But then I also like to look at the audience that is acquiring software, or those that are buying, or the end users in this category of what I'll call verify what you buy. And think of the people that are really concerned about this as being not just the IT operational people that are looking at various, whether it's software provisioning and deployment requirements, patching and software updates, or people from the risk and compliance group that are looking at what's our software asset management group, what's our level of risk as a result of this increasing vendor risk, software vendor risk scenario. In other words, are our software publishers truly trusted software publishers? What do we need to do to validate that software before we accept it and bring it inside our organization? What can we do, or what do we need to demand from our vendors? And so I just want to keep this paradigm in mind as we drill into this. And I'm going to specifically look at a couple different call outs where I think various inspection points or new inspection points, beyond looking at source code, if you will, because I do want to focus on the secure what you build primarily. But let's look at what we can do to inspect builds. I know a lot of people are doing some high levels of automation in this area, and got a variety of tools to build and automate that process. We also know that there's a gate when you create that gold image, if you will. In other words, what sort of release validation happens. And then, as we'd mentioned, if you're an acquirer or someone that's actually going to take the product that's been produced, do you have to have an independent acceptance process in place to essentially verify? It's that old adage, trust but verify. Go through that verification process before you take that software and push it across your organization. And so wanted to call out some of the highlights just to start to illustrate where risk resides. The reality is most commercial applications, mostly out of a sense of expediency and simplicity and getting product to market faster, are using third-party software. And most of that, in this case, the stats suggest 96% of these commercial applications are using open source components. We also know that within the application environment, known vulnerabilities do exist. And that's sort of a gating decision that's made at the time of release. Is that good enough? Is it, what's the level of risk? Are they, what's the criticality of the bugs or the defects that we know about? And is it going to really impact our ability to actually issue a patch or an update downstream to address it, and we get our product out the gate faster? We also know that orgs typically push vulnerable code out. In other words, those criteria that we just spoke about happen every day. Those discussions happen every day. So, it's a business decision, often predicated on a perceived risk within the engineering teams and the product teams, and the numbers are for the novice, you would make the assumption that those are high, but that's the reality that we live in. And then the last one I just want to say is, like, look, there are a lot of known flaws out in the environment, particularly in the open source realm, but there aren't very many mechanisms to track those. And so there's a few emerging vendors that are starting to provide that sort of set of capabilities. But the reality is these particular statistics just illustrate a degree of risk that I think even through the executive order, they're sort of suggesting, look, we're going to start looking at this from the outside in, and we're going to see a little bit more stringent control, which is, I think, a prudent decision. Now, what makes all this even more challenging is that the environments that this software is built in is very complex. There's a variety of different platform technologies. There's a variety of different repositories, some of which are the foundation for those technologies. Some of those technologies are vendor-based, and you may have these repositories. You may be drawing from the cloud. You may be replicating a lot of that content within your own environment. But the reality is, between all of these other sources of software and the various functional requirements of that software, what sort of packages are you going to download in the libraries? What are their behaviors? Do you understand them? Do you understand what those good behaviors are? What sort of dependencies do you have relative to the operating environments which these various platforms are working at? What sort of deprecated environments do you also need to be cognizant of? And so I'll call it almost the nth degree complexity associated with all this just makes the overall risk a little bit higher than I think what we would all want to expect. And so in the context of SolarWinds, I want to just illustrate another level of complexity or challenge, if you will, for the security providers. And this is one where the SolarWinds installation, the ISO package, if you will, I'll just refer to it as the installation package, so we don't, we can be a little bit more generic, but in excess of 100 gigabytes. Now, the middle diagram where it says that, if you look at that large installation package, there's over 600,000 components within that package. Now, what sort of tools do you have today to give you visibility into those components? Now, what's odd is once you get inside and you start looking at all those components, the fact is a lot of these things are recursively packed. This particular illustration only goes one level deep. In other words, we've got white boxes that say, look, there's another sort of packed set of files or binaries that exist. But you could actually have boxes within boxes, or on this ongoing recursively packed environment that, again, beyond size, there's an added complexity. In other words, how can we actually unpack all this to get down to the fundamental components, which in this illustration would be the black dots, to understand what that particular component's behavior would be if it were to run, and would it be indicative of bad behavior that would introduce greater risk to the organization. Now, ideally, whether you're a builder producing a bill of materials or someone that's acquiring the software or purchasing that software, you would like to have a bill of materials, and ideally you would break it down so that you understand, hey, what type, what sort of files exist. So you need to, again, break it down to the fundamental components, what sort of formats exist, was malware detected, and I would argue that AV is not going to get you there because they're not going to, one, take on files of this size or have the ability to break down these large installation packages to their fundamental components. So then you want to make an assessment of what sort of third-party components exist within that environment. So yes, if you're quote unquote a builder or a supplier of software, you probably want to do a check at a variety of levels around the open source or third-party software that you're using. But more importantly, if you're a consumer, you want to have visibility into those things so that if there is an identified risk in that environment, you have at least some understanding of what software have I purchased and implemented in my own organization that could potentially have this. So that you don't have to rely on the vendors to make that notification for you, because in fact they might not have had the information. And then so it continues to cascade down, and some of these will be sets of capabilities or information that reversing labs would provide. But you can see there's just a challenge when you're dealing with these large installation packages across a variety of different environments. Now you've got concepts of containers and things like that, which take it to another level. But there's again a level of visibility that we all need in order to make an assessment of risk and whether malware exists and whether the business is susceptible to an attack. And so the big questions are, can you trust your software? And can you prove it? Is it compromised? In other words, does it have malware that, unbeknownst to you, infiltrated your build process and your release process, your engineering process? Is it vulnerable? In other words, do you have a good handle on vulnerabilities, not just in the software that you're building, where capabilities or tools like your application security testing AppSec environment or tool sets can provide at that source code level. But more importantly, what do you know about vulnerabilities in the open source software that you're using? Again, 96% of your software is going to be from this third-party source. So again, a good question. Then lastly, is it coded properly such that it has some of the, I'll call it, self-defending capabilities enabled? In other words, are all those mitigations active? And so there's a lot of big questions that would arise when you're looking at software, not only that you're building, but also if you're purchasing software, acquiring software. And so a simple illustration of the landscape of what I would call well, let's just call it the software security or the software environment where security fits in particular. And so within the supply chain, we're going to see tools like SAST and DAST, or static application security testing, and dynamic application security. And there's a variety of other flavors as that industry continues to mature. But they're obviously sitting down there looking at, what's the, what does the fundamental code look like? It's more of a sort of an analysis of the code itself. But then there are some capabilities that say, look, we understand that you're going to, pack and assemble things. And so there are technologies around software composition analysis, or SCA, where they're going to provide some level of unpacking and what I'll call deobfuscation, which is a great place for malware to hide. We also have malware detection capabilities in certain, that can only get you so far. In other words, AV is going to assume, in most cases, okay, I've got maybe upwards of 200 megabyte, 150, 200 megabyte that I can analyze. And oh, you know what? If it's packed too much, maybe more than 5 pack, or recursively packed 5 times, I might be able to decompose it within my own environment if it's meeting a certain set of file formats, etc. But the reality is, often traditional AV is going to break down even at the malware detection level. And then you have the traditional vulnerability management side of the business, if you will, and looking at the potential vulnerabilities that can be identified within the software life cycle that you're working within. And so a little bit more detail on the application security testing tools and the software composition and analysis tools. Won't necessarily drill down into these, but I threw a few vendor names on there just to give you a sense of who they are and where they play. And so the reality is, and I'm going to be sensitive to time here, but there are a lot of things that we assume that simply aren't adequate. And so I'm going to take just a quick call out relative to the developers or the engineers that are building code. and what some of these myths might be. So the fact that they believe that they're securing their source code, the reality is it's not enough. The build machines very likely could be compromised, and in the case of Sunburst, that was one of the the key factors in that breach. So securing the source control itself is simply not enough. You've got to look at tools beyond the traditional SAST and DAST environment. Scanning the source code for potentially malicious content is not enough. In other words, has it been compromised? And again, the traditional tools that are in place today aren't proven or showing that they don't help in this particular area. Would scanning binaries for malware be enough? No, the reality is that's not. In the case of the Sunburst environment, and again, these are clear gaps that existed in the tool set at the time of the attack. The backdoor was well coded, it was well hidden, and it did not have a known signature. And so all these sort of things raise a red flag around, okay, what am I going to do to fill these gaps? And so certain things need to be added into the I'll call it the tool set, the control set within the application development environment or the software development environment. And we would say that the defense requires really a new process. And let's move it, there's a lot of conversations about moving left, but in some cases, there's other activities that are happening in that software development lifecycle that you want to be able to pick up and detect. And so an argument can be made that says, look, you actually want to look at the gold image and make that assessment toward the end as well. Clearly you want to have inspection of the software throughout the lifecycle, but you need a gating set of activities to inspect the software. I think being able to understand the behaviors of all the components, in other words, when I say software, that installation package or that application, and all the components that are within that installer. And we saw that illustration where we can begin to see that there are thousands, tens of thousands, hundreds of thousands of subcomponents from a variety of sources that actually comprise that ISO. You need to get down to those fundamental elements and understand what those software behaviors are. And so in looking at the software deployment risk, there's a variety of other factors that simply aren't even looked at today, I would argue. Yes, they're going to look at, in most cases, some known vulnerabilities, but the next 5 items in general might not be addressed. What are you doing to check to ensure that various mitigations are enabled, some of these particular capabilities to help the system defend itself against attack? How do we know that all the digital certificates, what's either signing applications or certificates and keys that are used in the process of gathering the data, that those are valid, they're not malformed, or they've been compromised? Have I inadvertently left sensitive keys or other sensitive information inside the code? How do I detect whether that's there later in the cycle once it's already been built? Are there other what third-party components exist, and how do I know the integrity of that content? Is malware already embedded in that image? In other words, yes, it's gone through the whole process, it's been built and it's been compiled and it's been released. How do I know that what might have been a good file yesterday isn't actually malicious today as I get ready to release this product? So what can you do to do that final check and make sure that your software is malware free? And so I'm going to quickly go through 5 ways and then give you some insights into reversing labs. First and foremost, put some of these controls right into the CI/CD process and let it play within that automated environment. So make sure that you simply integrate into that DevSecOps process. So be able to support, part of that automation is supporting build time analysis. In other words, don't be quite as stateful. If you can do it, if you could do one, going back to the original diagram where we're going to do that build inspection, verify the release and validate at the acceptance. What can we do to actually not just do real-time analysis, but actually do those checks at a particular points in time, as more and more components are introduced, or systems or processes or other touch points where attackers could infiltrate the software that's going to be released. What can you do to provide checks along the way. And so the second item is being able to actually automate that file analysis. In other words, yes, I've got a big ISO package, and you could, potentially just send it over to some guy that can sort of reverse engineer that ISO and start to break it down. But that's going to take days, weeks, or months. What can you do to actually automate that process? And so one of the classic examples that we look at is a real-time scenario. And this is actually reflecting one particular file that was identified as suspicious, where the manual process took upwards of 7 hours to do one file. What if you could do that in less than 1 second? And so if you look at 600,000 files, okay, it's still going to take a little time, but after that time runs, it's not going to be weeks or months. It's going to be a much shorter amount of time. It's going to be within your release criteria. Let's leave it at that, and the timelines that you have to get projects done and out the door. And so concepts like automated static analysis and IOC, or indicators of compromise, being able to extract those behavioral tags, if you will, is important. Providing some level of what we call actionable intelligence, in other words, some explanation of what your findings are in a language that both engineers and security practitioners can leverage. And just make sure that you've got the tools in place to deal with these large file structures, these large archives, installers, however you want to refer to them, packages, because we know AV and some of the traditional tools, which have value, but they can't deal with the form factor of these particular entities. And so they can have a role to play, a contributing role as you break things down, but something's got to go through the process of decomposing these items, looking at all the attributes, and again, certificates and some of these other things come into play. But then more importantly, drilling down and decomposing each of these files in a way to understand their potential behaviors and whether they're malicious or not. I would encourage everyone to validate third-party and open source software. And I would argue there's a variety of different sources. If it's open source content, you might want to look for a vendor that's actually already inspecting those public repositories and getting a head start on whether malicious content exists. Often we do that at Reversing Labs and notify the open source community where applicable of risky content that might exist out there. Sometimes you'll see things like typo squatting or whatever, and people get into those open source communities and think they're downloading something that is good when in fact they've typed something wrong. It looks right, but it just isn't. And they inadvertently download a package of malware. Want to go through that process of validating the gold standard? We would argue, make sure you leverage curated open source software. In other words, software that you know has been checked, if you will. So you have incrementally more trust in that software. I would argue you want to scan before any sort of repackaging and distribution. And then lastly, and we're going to talk about that here in just a second, but the ability to actually rescan or retro scan historical content, because like I said, at any particular time, files and software gets reclassified as we learn more about the attacker landscape and how attackers are building their software. And so what might be good today might not be good tomorrow. And you want to have that historical perspective across all the software you've produced, because not always are customers updating to your latest release. So that deprecated content could be malicious, and you need to inform your customers that implement your software. Fourth, and this gets into that retrospective analysis perspective, but you need to have the metadata that's associated with your installation packages and all the files that correspond to that build or that release. And so that metadata repository, or that data lake, provides a facility that you can actually do this retrospective analysis. And what we found, and it's often used by threat hunters and the like, but Yara and the Yara language, if you will, and the ability to create rule sets to look for potential bad behavior on not just the data that's derived for your current release, but all the data that's associated with prior releases. So you have that ability to retrospectively go back in time. And then lastly, make good use of not just your CVEs and your understanding of the vulnerability landscape, but also have an understanding of the files that are being used in that software build, and if there's malicious content in there, how those particular files are looking to exploit certain vulnerabilities. And so you can make that mapping. It helps prioritize where you focus. And so vulnerabilities for vulnerability's sake are good, but if the malware that's looking to exploit those might not be present, a little less important. But if you start to make some of those mappings, you can better prioritize. And so from an engineering perspective, you want to ensure that the software and the files that you have aren't susceptible to known vulnerabilities. And so lastly, as part of advancing your application security environment, I would say adopt good security practices and look at various programs or frameworks to help guide you. I'm not marginalizing any of the existing AppSec tools because, again, I think moving to the left and doing things at every point in the process is getting incrementally more important. My argument would be is let's do a check as you compile and you pull a variety of components together from various third parties and open source software environments. And then more importantly, as you go through the process, make sure that the tools themselves haven't been compromised. And so when you get ready to release, do that final gold image check. And so there's a lot of different tools that could be in play. And from a reversing labs perspective, we're going to say, look, you want to fill the gaps, and reversing labs has a role to play as part of a continuous assurance process. Use curated open source and implement, I'll call it secure coding training, so that we can continue to blend the dev and the sec in the DevSecOps environment. And so what does reversing labs do? Well, we address a lot of those things that go beyond what I had mentioned around vulnerabilities. We'll look at getting you the fundamental package contents clearly identified. We'll go through a certificate validation, look at various vulnerability mitigations, help identify whether sensitive information has been inadvertently left in the code base and it's wrapped up into the release. Identify what sort of anomalous behavior from the content that is within that installation package, so you can make some assessments on mitigating those risks and more importantly building better code. And then lastly, looking at all these third-party components and what we know about them relative to the risk that might exist within those. And part of this is actually looking at what we'll call dependency changes, or simply just added or deleted indicators of compromise, which would be indicative of changes in the software between releases that may or may not be what you yourselves as an organization had introduced. And so this would be a quick illustration of a sample report that we would provide as a result of consuming and decomposing and analyzing your installation packages to give you some assessment of whether you're truly prepared to release your software. And this would be an example of a diff, if you will, between various releases. And you can see in the case of SolarWinds and the .NET DLL, and I can't recall what that particular one was called, but the compromise released actually had a variety, and the red boxes indicate the added indicators of potential compromise. In other words, new behaviors that were introduced in the software, or potentially introduced in the software, that we identified that would suggest, okay, we need to go back and understand why these ads exist, and was that a result of a compromise? And so, in closing, I want to make an argument for the fact that, look, understanding the complexity and behavior of malware, and more importantly, all the components that go into building software, whether it's looking at certificates or whether certain mitigations are enabled. And again, if we're going to break down the installation package to its fundamental components and files and binaries, and we're going to provide a teardown of each one of those and get to the most granular metadata, and we can identify where other maybe sensitive data has been, I'll say inadvertently wrapped up into the code release that a hacker could potentially get access to. Probably want to serve that up as a vendor. So if we have that capability, that's a great thing. So anyway, the premise being a lot of consumers, if you will, of new intelligence about the digital landscape as more and more businesses go digital. And so yes, we know that the Security Operations Center, or the SOC, has been big consumers of threat intelligence. I think part of the proposition here is that you as engineers or part of the DevOps team Um, also have to understand the nuances of potential malware in your environment, or being able to interpret these types of security summaries or analyses of the software that's going to be deployed. And so centralizing, if you will, an analysis team to help with consolidating these skills and the expertise to interpret some of the data as a result of all this analysis is a great advantage. We call it a malware lab because in many cases we cater to the security operations center. But you're going to see reversing labs rebrand a few things around software assurance and the associated services to help people build and bring better software to market. And so with that, I'm just going to say thanks for attending. A few resources you can go to online to learn more about reversing labs. And I'll just say thank you and give you a few social resources if you want to follow reversing labs or watch what I'll call some very instructional videos on software development lifecycle, reverse engineering, threat hunting, things like that on our YouTube channel. So thanks again. And I greatly appreciate your attendance here at Purple Hats and attending our networking session. Thanks.